What we have done? First we carried out sedimentation. Primary sedimentation is carried out. If you have done primary sedimentation, wastewater flow, liquid wastewater in the top, and settled sludge solids. Settled sludge solids at the bottom. Now, this is a settling operation carried out na PST. Till now what we discussed about this sludge, where this sludge is going, till now we discussed. Please tell me where this sludge is going. This sludge is going to activated sludge process. Sludge which is settled in PST, that is gone. Just now we discussed till now about it. That is about activated sludge process. Now, the top liquid with impurity, we call it as effluent from PST, liquid wastewater. But according to primary sedimentation tank, it is effluent only na. According to primary sedimentation tank, it is effluent only. That is given to trickling filter. That is given to trickling filter. Clear? What is coming for trickling filter? Effluent liquid wastewater from primary sedimentation tank. Clear? Liquid wastewater effluent released from primary sedimentation tank. And also, I will tell you, and also, so from secondary sedimentation tank after ASP, this is a chart of activated sludge process. Chart of activated sludge process. Settling occurred here or not? Settling occurred na? Settling occurred. Secondary sedimentation takes place. Where liquid is traveling? Please tell me. Settling occurs. Understand? Settling takes place. Settling takes place through SST, secondary sedimentation tank. Secondary sedimentation tank. So where it is going again? It is going again to trickling filter only na. Good day. Yesterday also I told you, asked the same question. After complete theory of sewage treatment completed, I will do PYQs, numericals, practice questions, everything I will finish. Again topic by topic. Again topic by topic. As of now scheduled theory session. Again I will schedule from May 1st onwards. Only question practice session. Okay. First you learn the theory session. Read it, practice it. Then come to question practice session. So that topic by topic will continue question practice session. Okay. Now, this is the trickling filters. Understand now. Trickling filter will receive effluent from primary sedimentation tank and also effluent from secondary sedimentation tank of activated sludge process. Secondary sedimentation tank of activated sludge process. So it is simply like filtration operation. Trickling filters is simply like filter operation. So these are the filters. I will show another picture, it is easy. So this is the filter media. This is filter media what we have provided. This is the total filter media. Like whatever we have studied in basic filter operation. So the filter media provided here. Yes, correct Agnishek. Filter media provided. What is filter media? Filter media provided is broken bricks, broken stones, broken bricks, broken stones, or gravel particle. Any inert media we will take. Any inert media we will take. And now what happened to that inert media? So for example, this is the inert media you have provided, okay? And this inert media, it has been layered with, the inert media has been layered with attached culture of microorganism. What is the name given to attached culture of microorganism given inside the inert media? Have you differentiated now? This is inert gravel media. Gravel, broken bricks, gravel, or any inert media layered, surrounded by biofilm, layer of microorganism. Biofilm this is. Biofilm this is. And this is media, inert media. Yes, attached. Saksham Gupta, you want to make bacterial layer to be attached. Sand diameter is very, very small. Bacterial attachment is less. So if you take a particle of very finer sand, this is sand. How much thick bacterial layer can you give? Not possible. No? At least biofilm layer we can give 1 mm to 2 mm thickness. Even sand particle is not 1 mm thickness. How can you give a biofilm layer of 1 mm to 2 mm? So we are not at all selecting sand particle. Bigger diameter, minimum 3 mm to 30 mm diameter particles. Understand? We don't have sand with 3 mm diameter. That is why. That is why. So biofilm or bacterial culture attached on the surface, inert media. So trickling filters we are discussing. Trickling filters we are talking. We name it as aerobic attached culture system. Aerobic attached culture system. What is the meaning of attached culture system? Bacterial layer. What is the name of bacterial layer? Biofilm. Bacterial layer which is named as biofilm. Bacterial layer attached on surface of inert media. Bacterial layer attached on surface of inert media. Then will organism is moving somewhere? Will organism has the ability to travel throughout the system, throughout the flow? No. Organism is stable. Food chase organism. Food chase organism. Organism is not at all available, not at all moving, not at all going somewhere. Food is moving because flow is traveling. You are giving a filter media attached with bacterial lining. So this is filter media provided. This is filter media provided. Now flow, sewage with organic matter is traveling through it. Is not it? Sewage with organic matter is traveling through it. So bacteria is statically present at one location on the media. Organic matter, food is going towards the organism and utilized. So we can say in simple, in a single statement, I will give you very good clarity about it. Trickling filtration. Correct Agnishek, bacteria immovable, food is moving. In a simple single statement, I will give trickling filter. Aeration plus filtration. Trickling filters are nothing but raw sewage aerated and then filtered. So filters with some modification, filtration with some modification. Filters are layered with bacterial lining. So in a single statement, trickling filtration, aeration with filtration. So this is the aeration device. You understand? This is the aeration device, raw sewage. Here inlet Q in, we are giving Q in, raw sewage or else effluent from PST or SST. Raw sewage or effluent from PST or SST loaded here, traveling. Then it is released through the sprinkler system. You are observing in agricultural lands, irrigation process, sprinkler method. Rotating sprinklers are there, rotating distribution system. This rotating arm, this is called rotating arm. Rotating arm. In sprinkler irrigation, it is rotating continuously, rotating. So sewage is fall down. Understand? Sewage is falling here. Na? Sewage is falling. During the journey, what happening? Aeration happened during the journey. During the journey, what happening is nothing but aeration happening during the journey. Sewage drops onto bed. This is filter. Sewage drops onto bed. This is filter. Raw sewage particles fall down. Aerated sewage particles fall down onto bed. This is bed. Sewage fall down onto it. Filtration going on. Clear? Clear? So this is practical picture. This is a textbook picture for your easy understanding. The rotating disc will release sewage into filter media. Rotating disc is releasing sewage into filter media. Now, the filter media, what it contain? Please tell me. Filter media contain bacteria, is not it? Filter media internally contain bacteria. So that bacteria present in the filter media will perform degradation. Bacteria present inside the filter media will perform degradation. After degradation, what happening? After degradation, organic matter converted to inorganic. Now, wastewater with inorganic solids given. Impurity. So, organic converted to inorganic fall down. Now, wastewater with inorganic given to, again given to, tell me what? Secondary sedimentation tank. Wastewater with inorganic matter given to secondary sedimentation tank. So, inorganic sludge which is inorganic. Sludge which is inorganic, what it contain? It contain nitrates and sulfates. Sludge which is inorganic carrying the solids, nitrates and sulfates, settled. Where settled? Secondary sedimentation tank. Again, if the untreated wastewater if required, again we are pumping back into trickling filter. Recirculation, pumping back into trickling filter. Recirculation. Is that clear to you? I will make a note of it. Don't worry, I will give the statements and in the form of a diagrammatic representation charts. So this is one more diagram. Just they entered through this pipe rotating distribution system, passes through filter, then exit through outlet. So I will make a note very clearly, easily. Effluent from PST or SST, effluent from PST or SST loaded into rotating distribution system. What is the work done by rotating distribution system? Please tell me. Effluent or liquid wastewater from PST or SST loaded into rotating distribution system. What is the work carried out by rotating distribution system? Anyone tell me? Good. It is doing aeration. Rotating distribution system is performing aeration. Now aerated sewage. So that is aerated sewage only now. Aerated wastewater. Clear? Rotating distribution system is performing aeration. Good Agnishek. Aeration and sprinkles over the filter. Now that aerated sewage is loaded into trickling filters. Aerated sewage is loaded into trickling filter. Now what the trickling filter will contain? Trickling filter contain biofilm, bacterial growth. Clear? Trickling filter carry biofilm. So trickling filter will perform degradation. Trickling filter carry microbial layer. Attached culture system na. A swing in a park is not trickling filter. Aeration system provided is swing in park. Understand? Good day. The swing going on in park is a model of aeration system. The same model of aeration system we are employing in trickling filter. We are using in trickling filter. Degradation by attached culture of bacteria. What we call? Attached culture of bacteria, which is called biofilm. So whenever degradation completed, organic solids converted to inorganic. Now it is given to secondary sedimentation tank, SST. Understand? Degradation carried out by biofilm, so that organic converted to inorganic. Degradation carried out by biofilm, so that organic converted to inorganic. So as a result of secondary sedimentation, what is the result of secondary sedimentation? As a result of secondary sedimentation, we have two components. What are the two components? Settled sludge carrying nitrates and sulfates. You know it already written. Settled sludge carrying, no problem, you simply throw it, discard it, because these are harmless. You may use it as manure also. Settled sludge carrying nitrates and sulfates, you may use it as manure also. And what it carry remaining? Effluent. So where you are sending this effluent, can anyone tell me? Please? Very important regarding effluent. Anyone tell me? Very important regarding effluent. Effluent with BOD less than 20. If BOD of effluent is less than 20, you achieved your target or not? Palani, do you achieved your target or not? If effluent BOD is less than 20, our target is achieved. Disposal into river. BOD of wastewater from trickling filter. Very important point, this one, remember. BOD of wastewater less than 20 milligram per liter. Your target of sewage treatment objective is fulfilled successfully. Then if not, BOD of effluent greater than 20, you have not achieved the target. Still treatment needed. BOD greater than 20, still treatment needed. So recirculated again to trickling filter. Understand? This is the whole process of trickling filtration. This is the total whole process of trickling filtration. Is it clear for everyone? Anything I have to repeat in it? Effluent with BOD less than 20 given for disposal. Effluent with BOD greater than 20 again sent back, recirculated to trickling filter. Got it? You understand? Done. We'll move on now. We'll go ahead now. We'll move on now. These trickling filters, again we have been classified. Into three types. Contact bed trickling filter, intermittent trickling filter, contact bed trickling filter, intermittent trickling filter. Yes, correct, Umapati. In activated sludge process, we recirculate sludge. In trickling filter, we recirculate effluent, no doubt. Standard rate trickling filter. Standard rate trickling filter, also called as conventional trickling filter. settled sludge, nitrates and sulfates are in the form of nutrients. Correct, Agnishek? Correct. Settled sludge, nitrates and sulfates, we analyze the solids. The solids are good, it was given for drying. After drying, that nutrients can be used as manure in agricultural land. If we analyze it, it carries still some impurity. That sludge given to sludge digestion after that drying. Understand? Settled sludge is analyzed properly. We find that no harmfulness. Give it to drying and after drying use it as manure. If you find that some harmfulness is there, give it to sludge digestion. After digestion and drying use as manure. Now contact bed trickling filters. Where contact bed trickling filters used in villages, broken bricks is the filter media. Contact bed trickling filters used in villages, broken bricks is the filter media. Rate of filtration is 1000 to 2000 liter per day per meter square. Very low, because not required. Village water quantity is very less. Low rate of filtration is enough. 1000 to 2000 liter per hour per meter square. And here efficiency also we are not expecting. Efficiency is around 90 to 95, because we have given low rate. 90 to 95%. Then when it is coming towards intermittent trickling filter, understand this is contact bed information. When you are talking about intermittent trickling filter is used in hospitals. The media is a specialized media. Intermittent trickling filters used in hospitals, especially the hospitals which treat the disease tuberculosis. So it is wastewater from hospital was taken, given to trickling filter. After trickling filtration it is given to STP, not directly given. Understand, this is the chain. Wastewater from hospital wastewater, because it contain impurity from patients, it is given to trickling filter. Then after that it is given to STP. So within the hospital itself, first it can perform trickling filtration. After that it is given to domestic sewage treatment plant. Understand? You understand that? Directly wastewater from hospital not allowed to release into sewage, domestic sewage. First it should treat trickling filtration. After that it should treat with the secondary. After that it was given to sewage treatment plant. Here efficiency is not an issue. Trickling filtration efficiency is 60 to 65% only, because after that you are going again full length of sewage treatment. If only trickling filtration is done, you can go 90 to 95%. But not only trickling filtration. After trickling filtration it is going towards STP, sewage treatment process, where efficiency is 60 to 65%. Understand, this trickling filtration efficiency 60 to 65, no problem, because next treatment will take a next full length sewage treatment process is there. Now this is what we are using in our municipal domestic sewage treatment plant. Standard rate trickling filter, conventional trickling filter, municipal domestic sewage treatment plant in towns and cities. City and town municipal sewage treatment plant will carry standard conventional trickling filter. Again, it is differentiated into low rate conventional trickling filter with 2000 to 3000 liter per day per meter square rate of filtration. Low rate conventional trickling filter with 2000 to 3000 liter per day per meter square. And here no recirculation carried out. No recirculation carried out. Not conventional, it is a specially designed good day. Those are specially designed for villages, those are specially designed for hospitals. The conventional is standard rate. No recirculation, still it achieves, because of low rate, it achieves 90 to 95% efficiency. Still it achieves 90 to 95% efficiency. Then we are talking about high rate conventional trickling filter, high rate CTF. High rate conventional trickling filter shows 3000 to 6000 liter per hour per meter square. Very important. Very huge rate of filtration. 3000 to 6000 liter per hour per meter square. Very big rate of filtration. Huge. Recirculation is mandatory because you are increasing rate of filtration. Understand? You are increasing rate of filtration. So recirculation is necessary, mandatory. As we are performing recirculation, its efficiency go on increasing 98 to 99%. Efficiency go on increasing 98 to 99%. Clear? Again I am repeating. Standard rate trickling filter, low rate and high rate. Low rate 2000 to 3000 liter per day per meter square. Recirculation not carried out, only one time trickling filtration done. Achieves efficiency 90 to 95%. Because already it is going very slow, trickling filtration going very slow, so that again recirculation unnecessary. High rate conventional trickling filter 3000 to 6000 liter per hour per meter square. Fast rate of trickling filtration. So recirculation is mandatory, shown with efficiency 98 to 99%. Done. And regarding trickling filter, you need only one formula, which is called NRC formula. Only one formula, mostly not required, by chance given we are learning. NRC formula for efficiency of trickling filter. 1 by 1 plus 0.0044 root u into 100. 1 by 1 plus 0.0044 root u into 100. What is u? Organic loading rate. U is organic loading rate. Which units it is taken? Which units organic loading rate is taken? Please tell me. Kg per day per hectare meter. Remember this, not meter cube. In this NRC formula, you are taking organic loading rate U in terms of kg per day per hectare meter. The same formula you can equalize with regular BOD rate removal efficiency, Yi minus Ye by Yi. Influent BOD into effluent BOD by influent BOD into 100. Efficiency is equal to influent BOD minus effluent BOD by influent BOD into 100. By that, you can achieve, means they will give 3. Influent BOD, effluent BOD, organic loading rate, you can estimate efficiency. They will give efficiency organic loading rate, influent BOD. You can achieve YE. So out of the three parameters YE, YI, U, two provided, one to be determined. That's it. One to be determined. kg per day per hectare meter. Palani, not hectare, hectare meter. It is volume only, volume in terms of hectare meter considered. Palani. Done. And here recirculation factor. One more thing you remember, recirculation factor F. In denominator only, recirculation factor. You are writing like this, kg per day by hectare meter. You understand now? Good day, you understand now? Kg per day, volume in hectare meter. Recirculation factor F is equal to 1 plus return flow QR by original flow Q divided by 1 plus 0.1 into QR by Q whole square. Recirculation factor F is equal to 1 plus QR by Q by 1 plus 0.1 into QR by Q whole square. 1 plus QR by Q upon 1 plus 0.1 into QR by Q whole square. Is that clear? Now, very important, for low rate trickling filter, F is equal to 1 because no recirculation. Recirculation is 0, QR is equal to 0. For low rate trickling filter, recirculation not happen, QR is equal to 0, so that recirculation factor F is equal to 1. Recirculation factor F is equal to 1. Now, for high rate trickling filter, recirculation factor F is greater than 1. For high rate trickling filter, recirculation factor F is greater than 1. Clear? Clear for everyone? F is equal to 1 plus QR by Q divided by 1 plus 0.1 into QR by Q whole square. For low rate it is F is equal to 1, for high rate F is greater than 1. So this ends trickling filtration. This ends trickling filtration. We'll continue again